When we talked about exponential functions, we said that y is equal to b to power x. If b is more than 1, then we saw that we have an increasing curve. When b is bounded between 0 and 1, we have a decreasing curve. We are interested in finding the integral of b to the x dx. This integral is equal to b to the x divided by ln of b plus constant of integration. Remember that you can always check the work. If you take the derivative of b to the x divided by ln of b, it becomes, well, 1 divided by ln of b is just the coefficient. You can write it outside the derivative and then take the derivative of b to the x. As you remember from the derivative, it is equal to 1 divided by ln of b, and the derivative of b to the x is also ln of b times b to the x. So you can cancel out the common factor, you get b to the x. So since the quantity b to the x is the same as the function inside your integral, it means that your integral is correct. Now suppose you have the integral of 2 to the x dx. Following the formula, this is 2 to the x divided by ln of 2 plus constant of integration. If I ask you to calculate a definite integral, the definite integral of 2 to the x dx as x ranging between 8 to 9, this is 2 to the x divided by ln of 2 as x ranges between 8 to 9. This can be written as 1 over ln of 2, and then here 2 to power 9 minus 2 to power 8. If I factor out 2 to power 8, you get 1 divided by ln of 2, 2 to power 8, but 2 to power 9 is basically 2 to power 8 times 2, so you have 2 minus 1, this guy is just 1, so you have 2 to the 8 divided by ln of 2. This is your final answer. If you want to get an approximation, you need to use a calculator because ln of 2 is just a decimal number. The next famous exponential function that we are interested in finding the integral is the integral of e to the x. The integral of e to the x dx is e to the x plus constant of integration. You can easily check this work. The derivative of e to the x plus c is the derivative of e to the x plus the derivative of c. But the derivative of e to the x is e to the x, and the derivative of constant is just 0. So you have indeed e to the x, which is the quantity inside your integral. Now for the definite integral, we are using the same process, fundamental theorem of calculus. This is e to the x, while x is ranging between a to b. So you have e to power b minus e to power a. In calculating the integral of 8 e to power x, as x is ranging between ln of 3 to ln of 6. First of all, this 8 can be written in front of your integral. So you're left with the integral of e to the x that you know how to calculate. This is 8, parentheses, e to power ln of 6 minus e to power ln of 3. From algebra, remember that. When you have e to power ln of u, since e and ln are inverse functions, the outcome is u. So in either of these cases, you can get rid of e to power ln. You end up with 8 times 6 minus 3, or 20. So all of these are integrals of exponential functions, everybody. These are not power functions. Power functions are x to power n.